step you take, attention is left in your wake. Everywhere you see, blinded yet infinitely. The spectrum of our time breaks from its shape of a line. Each instance proves to me a moment reaching endlessly. Every step you take, attention is left in your wake. Everywhere you see, blinded yet infinitely. The spectrum of our time breaks from its shape of a line. Each instance proves to be a moment reaching endlessly.
Hello, everybody. I think we should be just about ready to go here. Let's see if that works. That does work. Oh, hey, look at that. It looks like I actually hit that lineup on the split quite well. So, I guess let's start things off by going over what exactly we're doing here. So, last week we started on a new series of streams. We were taking a look at VirtualBox because the VirtualBox is one of the pwn-to-own targets that's coming up in, end of March, so about a month and a half, give or take. I think it's, 45-ish days from now? So yeah, a month and a half. And here, I can even pull it up here. Come on. So this got announced about, 2-3 weeks ago. I want to jump to the contest details. That VirtualBox was yet again going to be a target. And if you were one of the people who happened to have a nice shiny VirtualBox breakout, you could walk home with $35,000. So I thought this would be a good opportunity to do some of the initial research that somebody would probably need to do if they were going to go after this target. And by that initial research, what I mean is we need to do a little bit of a survey to find out where bugs currently exist. We don't, strictly speaking, have to do that. We could dive in and try and find bugs on our own. But given the fact that researchers have already found and published, I think the count was 70 different. There have been 70 CVEs in the past year and a few days. It makes way more sense to start by looking at all those bugs. We can take a little bit of time, read through those bugs, and actually find out here is where real researchers are finding bugs. Here are the places in the code they're finding them, and here are the types of bugs they're finding. And the reason we do that is because most bugs are going to look at least somewhat similar to that. If most of the bugs are in these device interfaces between the guest and the host, it's relatively likely that most of the remaining bugs are probably also in similar but slightly different interfaces. This example here was last week. We went through two bugs. The CV 2018-2698, which was one of Nicholas B's old bugs, which was in this HGSMI interface. It was a way that the host and the guest could share a bit of memory, and they used that to do some sort of DMA for some sort of graphic stuff. We then took a look at this other bug, which was the CR server dispatch get active uniform function, and I didn't have as good of notes for this one. That's unfortunate. Or if I did, I didn't save them properly. Well, this was also in a similar interface. There was one of these interfaces that talked back and forth. Oh, it's up here. The VBox HGCM, which was another method for communicating between the host and the guest. And given that now we found two bugs like this, going through them, we're probably looking for something similar. One of these interfaces to talk back and forth between the host and the guest, but ideally not one that somebody has just found, 15 bugs in. The reason I say that is because these are the vulnerabilities that have been released so far this year. Well, I believe this is all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there's 17 here. Oh, no. 18, 19, 20. Okay. I believe this is all of them. There are 20 bugs that have been released or 20 CVEs that have been released for VirtualBox so far in 2019, or at least as of last week. I haven't checked in the past week if there have been another round of them, so hopefully not. But one of the things that was important here is that all of these that start with this CR prefix, they're part of the Chromium rendering. It's not the Chromium like the browser I'm using. It's a thing for graphics in VirtualBox because for anybody curious, Chrome in particular, the word Chrome gets used a lot for graphics. I believe, like, I don't know what the full history of it is, but my understanding it has something to do with the fact that it's shiny, and it was used in a lot of like automotive stuff to like add detail because it's shiny and it looks nice and it's relatively maintainable. So when people were building, things for browsers or for virtualization platforms or something like that, the developers were like, oh, this is kind of like the Chrome I put on my car, so they named it Chrome. I don't know. It's a thing. There's a whole bunch of different things related to graphics that are all called Chrome. It's super annoying when you're trying to do research into them because you can't Google for any of it. But anyway, that's what we're looking at. And we know that a lot of these, they all start with this CR prefix, which means the function where the bug is. So this CR server dispatch get map IV, or the CR server dispatch get active attrib, those are all in that same Chromium functionality. And given that one or more people went through and found 19 bugs in that same general area of code, it's at least somewhat plausible that people have gone through that with a pretty fine-toothed comb. What does jump out at me, and the first thing we're going to be looking at today, is this one. So all of these other bugs that were released this year were in the Chromium area. They're all slightly different. We have some uninitialized memory information disclosures. So these are probably something of the form where I, from the guest, request, give me 500 bytes worth of, or give me 500 bytes worth of data, or here is 500 bytes worth of data, return it to me. And for whatever reason, the data that comes back to me is just random heap memory out of the process, as opposed to the data it should have been. A lot of the time, this is because there's data that was supposed to be written into it, and for some reason, we've managed to make it so that no data was written into that area, and it just returns back what was there in the heap before. So if we were trying to exploit these, which at some point in the not-too-distant future, we probably will be trying to exploit one or more of these, what we're probably going to need to do is actually take something like the CR server dispatch get active uniform bug, which was, if you remember last week, this was the one where you gave it a size, it then checked to make sure it was less than max int over 2. And if it was, it would allocate that many bytes plus some header size. And the trick was that if that was a negative number you supplied, it passed the check, plus the header gave you a valid number of bytes to allocate, and then you'd write the header in regardless, and you'd bash a whole bunch of memory on a heap. The trick here, and the reason why that would be so difficult to land, is because that on its own is probably not exploitable. But if we paired it with something like one of these uninitialized memory disclosures, then we'd be able to get like the pointer out that we need. We'd be able to learn more about the host and memory allocations and things like that. And we could probably turn combining two of these together into a single exploit. So, I think that's about all of it. I'm trying to think if there's anything else that I should cover before we jump into just diving into the source code. Oh, I should update this over here, shouldn't I? So the one that we're going to be looking at... hello? I'm not crazy, right? I totally just heard, like... I heard something, right?
Notification overflow. Pain.
Oh no.
Tooltip. Realtek HD Audio Mat Taskbar. Sam at desktop.com 17.
Oh no.
/MNT/C live dashboard. Sticky keys window. Yes, no. Desktop 1 window.
Nope, stop this.
Live dashboard. You.
Okay.
Tooltip. Click to switch off.
Okay.
Window. Cortana. Search box. Editing. Item described by type here to search.
Oh no! So I've muted it so you guys don't have to hear this, but I'm trying to figure out what is that thing called? Oh no! It's one of the ease of access.
Search box narrator 2 of 4.
It's the narrator, right?
Notification Notification overflow. Pane. Tool to taskbar.
Nope.
Narrator settings window.
There we go.
To navigate the options in this dialog, including an option for the online user guide, press the up and down arrow keys. To review the full set of narrator commands, press General.
I want to just turn you off.
Launch narrator. Control plus Windows key and enter. For Windows, exiting narrator. Starting narrator.
I know you're starting. I want you to stop.
Narrator settings window. To navigate the options in this dialog, including an option for the online user guide, press the up voice speed 50% slider. Current value. Discard change in general. Checked enable the shortcut to launch narrator. Control plus Windows key and enter. For Windows to navigate the option exiting narrator.
Okay. There we go. Okay. Well, that was fun. I don't know how exactly that happened, but that was not what I was intending to have happen. So let's see here. Let's see if I can remember where we what I was trying to do before that happened. We were talking about if there were any other things I needed to cover here. Because this is the one we want to look at, and I was typing that in over here. CVE 2019-2446. Oh, it's the one that I gave an asterisk there because it's the one that matters. So we have that. We have this that we looked through last time, talking about the 3D acceleration stuff. We have a little bit of notes here. I think that's pretty reasonable in terms of covering things. Yeah, that sounds reasonable to me. So let's just jump into this. So we need to find this right here, the SVC. Well, actually, let's start by taking a look at this and seeing if they happen to give us any more information. Most of these were very little information. This vulnerability allows attackers to disclose sensitive information on vulnerable installations of Oracle VirtualBox. An attacker must first obtain the ability to execute privileged code on the target guest system in order to exploit it. It exists in the SVC get buffer method. The issue results from the lack of proper initialization of memory prior to accessing it. Okay. So, really, very little information about it. So let's start by actually finding this function. Okay. This is unfortunate. I know I talked about this before, but we have just enough files here that searching becomes difficult because I'm using WSL through their DriveFS file system, so it's a little bit on the slow side. Just because we're having to open so many files and read and write them in order to grep, it's a little slow. Oh, right, I was going to use AG instead. Because AG is going to be slightly faster. And by slightly, I mean like an order of magnitude faster. Actually, I think while we're waiting for this to go, I'm going to jump up for a second, and I will be right back. Wow, even this is kind of slow, isn't it? Did I break something that it's taking this long? Because I seem to remember these searches being, well, not, fast. Oh, a reasonable speed. Here we go. So this is... Oh, so it's still in the same Chrome service functionality, which isn't exactly where we want it to be. So let's see what we're dealt with here. So we have a buffer. I assume we're allocating a buffer, right? We're going to allocate a buffer. We allocate this P buffer. We then allocate a P data init. We set a UI ID. We set a few fields in it. So is this all just as simple as we're not initializing this data? If we already allocated it, we're going to, what are we going to do? If the UI ID is us, we're going to check to see, so size is not 0, and UI size does not equal the size we gave it. Interesting. We've got errors that'll return. Okay. Interesting. This is much simpler than I thought it would be. Well, let's take a look and see if that assumption we had there was correct. So, just to validate there, the assumption is that their fix is going to be to initialize this memory. So if we come in here, 524, and we want to edit that version. Yeah, that is actually exactly what they did. Their one change was going from rtmem_alloc to rtmem_alloc_z. Wow. Well, this was not as exciting of a bug as I was hoping it would be, because I was kind of hoping I'd take a look at this and it'd be like, oh, it's something complicated, but no, it's just they have one function that zeroes out allocations and one function that doesn't, and they use the one that doesn't. Awesome. Okay, let's see here. So this was much quicker than I expected it to be. Are any of these others particularly interesting looking? So we have integer overflow, uninitialized memory, uninitialized memory, uninitialized memory, integer overflow, out of bounds read. Let's take a quick look at this one. So in here, quit source VBox host services. So I think it's a safe assumption that it's going to be in the same area. Yeah. Unpack unpacker unpack shaders.c 346. Oh. Interesting. So is this thing just like... So I'm assuming these are all, like, the macros are reading off some buffer that's been set up. And we're just able to say, give me more stuff. Awesome. That it seems way easier than I would have hoped to exploit. Oh. Okay, so we have that. We have more out-of-bounds reads. Out-of-bounds read, integer overflow, untrusted pointer dereference. That's interesting looking. So it's not there. Ooh. Where is it? We're now having to search through a whole bunch of source code as opposed to just the little window we had before. So one thing I will say is, I mentioned this on Twitter, I'm not sure how long I'm going to be able to stream today. As you can probably hear a little bit, I've got a little bit of a sore throat, and I've had a pretty bad headache for the past couple days, but we're going to make at least some progress before I have to call it quits for today. At least assuming I don't keel over in the next 10 minutes. Well, I mean, we've already made some progress. We've got a good idea of how a lot of these bugs look, at least the most recent set. Which is quite a good start, right? So we understand that almost all of these, for whatever reason, are in this chromium area, which tells us quite a bit about how how they were all found, given that it means that a lot of these were all mostly found in the same 3D rendering code. It tells us a whole bunch about how it works. At least what areas a lot of the researchers are looking into. So we want to come in here. I forgot to see what line that was. 47. Ooh, this is some code in it. So what do we do here? We get some bits. What did we say this was? We said this was a untrusted pointer dereference. So this function accepts a size n and a list of IDs. And for each of them, we're going to get an object which is in this hash table. So I assume the bug here that we're looking at is it does not validate that ID's I is actually it's less than the size of the hash table. Okay, let's validate that that assumption is true. We want to come down here so we can actually look at it again. And we're going to edit this one right here. Interesting. So they just like got rid of this. No. Okay. That makes me feel a lot better. Okay. So we got a context. If n is less than 0 or n is greater than... Ooh, interesting. So they changed this right here. So it's now if n is greater than GL size I, so that's an integer. Oh no, that's a cat. So we're casting int32 max divided by the size of an unsigned int. If n is greater than that, then we fail. Then there's this whole check, which is gone. If not, data pointer check. N times size of. Okay. And then in this actual function. Interesting. So the issue here was that we could send an n that was bigger than an int32 max, which I assume would have the effect that So if we said here are, you know, a billion ints, it means that we would just keep doing this. That seems very tricky to try and exploit. But, okay. I'll buy that this is a thing. Okay, so what other bugs do we have here? We had those. We have more of these untrusted pointer dereferences. More undersized memory, undersized memory, undersized memory. Okay, so these look pretty much all the same. Unless there's any major details here, we can probably start on something new. Not finding a new bug. We're still not planning on doing that. But it is fascinating to me that a whole bunch of these bugs were all found in similar areas, but they were found by quite a few different people, rather than one person finding a whole bunch of bugs in the same area. I would kind of expect there to be like one researcher that came in and cleared out all of these, but the only person I see who crops up quite a bit in these from earlier this year was, so we have Nicholas B with 3 so far. And most of these are, I guess I'm not going to be able to pronounce this name properly. But this person has quite a few too. Interesting. So looks like this person found all of those dereferencing ones, which is kind of what I would expect, right? That they found one way to trigger this, they found one example of it, and they went through and they found as many cases of it as they could. And, you know, got paid for them all. The important part there, getting paid for it all. Oh, how did I miss this one? VSXL5.dll. Oh, because this is not in VirtualBox. Okay. My search here was incorrect. Last time I searched for the VirtualBox ones, I guess, and this one, there's a few non-VirtualBox Oracle products. And I just searched for Oracle because it's shorter. Okay, so that looks pretty reasonable running through those real quick. I think that gives us an idea of what everything looks like. Sorry. Okay, we've got this. Let's think about the next step here. We've got 2 big options of things that we can do as our next step. One is we set up a test environment and actually try and throw a couple of these. Basically, we would set up an environment and try, which is probably like one of these integer overflows, try and get a crash with it and start working with that. Alternatively, and it may make sense to do these kind of at the same time, we probably want to take a look at the guest editions. So based off of last week's stream, where we took a look at the guest editions, and in particular, there was that write-up for the first bug, which included, they had supplied a patch to the guest edition source code so that you could recompile it and you'd be able to actually send a specific message type across the bus. One of the things that we're going to want to do is at least the majority of the interfaces that are exposed to the guest are going to be included in those guest editions. So we can go through them, we can check, and we should actually be able to see, here are, well, the trick is, if we can figure out a good way to talk to each of the interfaces, we should be able to see in the source code those interfaces, if they're in some generic way, which, of course, they're not going to be particularly generic. So let's actually start there. If we go back to this CVE, so this was the CVE that we had this great write-up for. They actually took the guest edition source code. So yes, one of the options is to write it in C. The tricky part is that a lot of these interfaces are actually going to do a whole bunch of communication to set up that I would like to avoid as much as possible. Ideally, we're not going to actually do much of it at all. So, reading through this setup, you basically pull down the guest editions, you mount it, you run this thing, and then after you do that, you can modify, they've got the source code there for us to mess with, and we're able to then recompile it and have additional additions. Okay. They gave us the full source for their patched file, right? Yeah. Okay. Let's take a second to do that real quick. So I want to go... I know you can't see this. We have this. We're actually... Ooh, that's unfortunate. I don't have a VM built for this yet. Well, the good news is that I can pull this down and it'll work. Whoa. Is streaming working right? Yeah, you guys are should be getting full stream. I'm kind of surprised that my downlink is this slow if my uplink is working no problem. Okay. So I guess we're going to wait here for a minute while this pulls down, because unfortunately there's not much we can do without this. I guess we can actually go look at the guest editions, right? No, we don't want the source code. That is going to just crawl. And we want downloads. We want older versions because we want the 522. Oh. 522, and I want the 522.22 guest editions. I don't see it listed. Interesting. I'm not blind, right? Okay. I guess this is a thing. But I guess we're gonna have to let this pull down and work before we can do much at all. This is so painful. I feel like last time I did this, it was actually quite fast. So I'm not sure what exactly is going on with it, that it suddenly decided to take a shit and go in like a megasecond, if that, because I think it's actually slower than that, isn't it? Okay. So I've got that. We're gonna pull that down. What I want to do is I want to be able to read through this. So oh. Is it really just that easy? CD. Ha! Okay. That is just me, well, where is stuff in here? Do we have a... Oh. So at least the claim is that this file doesn't exist in the source we have here. What is this, though? This is Hugo that pointed this out. Sure, this is not in here. But it's right... Oh, it's a CPP file, not a C file. Okay. Take a look at this. This should be identical to the file from the exploit, only this version has stuff in it to actually create our interface. Let's take a look at that real quick, actually. So one of the things that whoever put together this write-up and or exploit did was... Apparently I can't copy and paste very well. Is they set up a device in the guest that you could actually talk over. Oh, come on. Okay, we're just going to try and pull the raw version of this, right? View raw? Four, 3, 8, 7, 8. And we want to go to... Yeah, we'll just go to the... Yeah. Okay. So if we diff this and this, wow, that was a lot of diffs. Oh yes, I know I can disable it. I choose not to. The beeps tell me I'm doing things wrong. Why is diff so bad? Are those not the same thing? Okay, why did diff think these are significantly different? Interesting. It's interesting these two lines are very different. I guess, weird. I guess that this, the exploit code actually comes from a more recent version? Well, that's unfortunate. Why isn't diff working? at least this is kind of readable now. To start with, this is much longer. I'm really confused with why that's happening, because the first lines are the same. Are the first lines the same? Versus I hate Windows so much. Ooh, I have not seen this before. And diff NAUR. So U is going to be 3 lines. Capital N is new. NA. So the problem here is that the version I pulled off exploit.db is doing what is it, the /r/n endings when I don't want it to be. I'm realistically what I need to do is DOS to Unix. We pull this down. Yes, install it. Where are we at on this? Getting closer. DOS to Unix, this thing. There we go, much better. So what was happening there, right, was that because the version I pulled off exploit.db had the /r/n endings, because, you know, I was pulling it from a Windows machine. Was I? I was, but why would it do that? Doesn't matter. It was doing that, which meant that every line was different, even though it wasn't visually different. So interesting differences here. This is actually vastly different, isn't it? Huh. Weird. Is this not the same file at all? This may just not be the same file at all. I'm not falling for that trick. So what I'm curious about is, no, this is still roughly the same. Does this exploit just add a massive amount of code? Yeah, this exploit just adds a massive amount of code as part of it, because it ends the same, and they just added about 700 lines worth of code, which, I guess now that I think about it, 700 lines isn't that much, is it? Like, it's a fair amount, but it's nothing super crazy. Come on. We're going to finish our setup here. Continue. My name. My password. If somebody in the chat can guess that, I will do absolutely nothing except for tell you it was the correct password. Any guesses? It's probably your first guess. And now we sit and wait. We wait. Actually, now that I think about that, that's actually really weird, right? So this write-up is actually quite a bit after the oh, no, I'm going the wrong direction. This is 2016. Because the version of the blur, I'm gonna have to pull that in a very old version to actually make this exploitable, because this bug is not from 522. The 522 ones are these recent CVEs. It's going to be a little bit trickier, which means we should actually jump in here real quick and remember how they did it. So there was like a pwn in here, right? Yeah, we have a pwn request. We have pwn ioctl. Where is pwn ioctl getting added, though? Set this all up. Ooh. This is interesting. Sets up the HGSMI guest to host command context. Interesting. Huh. What is a MISC register? I don't think I've ever seen that before. But, you know, as long as it works, it works. If we take a look at this, we probably see that. Okay, you can go away. Oh no, I've put my super secret password on screen. How dare I? Okay. I know I should be using the like IP adder or whatever, but ifconfig is just very much ingrained in my head, and trying to shake it off is going to take way too long. SSH to 172.171.167.122. Yes. And then I want to do an SSH dot import ID, copy ID. 217.167.122. Okay. All good. So now we need to pull down the version of VirtualBox we want, which, because we want to land one of these older bugs, is going to be 5.2.22. This looks like what I want. And now we download. And we're downloading, and we're downloading. And I should be able to... Hopefully this works. Errors? Oh, I've got a lot of dependencies, don't I? Do they list my dependencies? Are they nice enough to tell me my dependencies? Oh, they are kind of a pain, aren't they? Okay, I guess I'll do this manually. Lib curl 4. I need a libqt5 core 5a, libqt5 GUI 5, libqt5 opengl5. Really? Huh. Interesting. No, it still didn't pull down some of the stuff it needed. Okay. No, don't do that. I'm doing this again just to get all those back here. I know you're going to fail. libcurl4, libqt5, opengl5, lib. This one I'm copy and pasting. Really? Have I broken my installation already? This is awesome. This is what I always wanted. Ow. Yay! No. Just reinstall it. We run you, what happens? GCC make Perl packages. Oh, I had no idea I could have apt install a Debian package. Huh. Today I learned. Interesting. Make Perl packages. What the crap does this mean? We are not rebooting this. You make funny joke. Okay. And again. And we're building kernel modules now. Ooh, do I need to change some settings here? Let me check that real quick. Yeah, we might have to make some changes to this. Yeah, we're just gonna kill you for a minute. Settings. We have a processor. Well, that looks okay. Isn't there usually a like setting in here that I have to change to let it fake out the stuff? Yeah. We'll let it complain. Oh, VirtualBox. Oh, I need an X server, don't I? Do I have an X server installed? I do have an X server installed. It would help if I could type. Okay, I need to do the thing with the thing, don't I? Well, or I can just use this, can't I? Yay! So test VM, we want Linux, we want it to be 64-bit because do I not want it to be 64-bit? Oh, is this it being awful because I don't have the VTD enabled? Yeah. Well, I guess I can live with that. There's no major downside. Yeah. I don't think there's any major downside to it. Other than it might cause a little bit of a problem, but I can live with that. Create, yes. Okay, and we need to get ourselves an Ubuntu disk image. I do like seeing that my Firefox is critically out of date. Yes, download. Okay, you seem even slower than the last one. Like, it was not this slow, right? I feel like it wasn't this slow. It can't have been this slow. There's no way. Come on, don't be a pain in the ass. Yeah, see, this is slow, but it's not like painfully slow. Okay, I guess we're gonna download this and then push it across the link. I can live with that. Okay, Okay, I guess while this is going, I'm gonna get up and take about a 5-minute break and grab myself a drink, and I should be right back. Probably back a little bit after 4, so I have a minute here. I will be back in just a minute. Thanks, everybody. This one. Okay, and we're back. Actually back now. Okay. Okay, let's see here. Where were we before we took a little bit of a break there? We had just downloaded this image, and I need to push it across here. I'm killing this download because, yeah, you still have hours left, and there is no way we're waiting for that. Oops, that's not what I want at all. Downloads. We went to SCP this to 172.16 dot, I forget your IP address. 17.167.122. Put it in your home folder. See, much faster than trying to go through it all manually. Okay, we have this, we have this. We want to build a VM now. So, start. I need to find you a ISO. Oh no. Oh no, crap. Son of a bitch. Of course I just downloaded the 64-bit version. Grumble, 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 grumble. I want a US host. Which of these looks nearby? Take one of these 20 ones. Sure. You seem fine to me. 1804. Is there not a 32-bit? Okay, 1604 it is. I can live with that. Whoa. Now you're crawling. Okay. But you said you were so fast. Let's check these guys. 1604 and I-386 download. There we go. That I can live with. That is a speed I can actually live with. Yeah, unfortunately, it's still slow and still painful, but we can live with it. So how's everybody doing? Yes, while we're waiting, we can chat a little bit. Hopefully this series of streams is at least interesting to people, getting to dig through a little bit of this kind of background stuff. Crap. I totally forgot to be recording this. Which means I'm going to have to jump through all the hoops to make the recap video again. That's a pain. So I complained about it on Twitter, and I don't have a good resolution for it, but apparently I guess I can stop recording and at least save some CPU that way. So apparently the way that YouTube handles things, the only download I can get of any of my videos is 720p. Even though I can upload, and like this stream is a 1080p stream, the video you're getting, if you if your download can handle it, you can actually get a 1080p stream of this, and it looks like about a dozen people are currently watching this in 1080p. However, the highest def version that I can actually download myself is 1080p, which means that I have to like go to one of those sketchy YouTube downloader sites to be able to download my stream if I forget to record it. Because reasons. Like, that thing has to then stream the entire video back because it's able to watch it in full def, but I can't download it because YouTube doesn't want me to like, I don't understand the reasoning there. I was struggling with it last weekend and like bashing my head against the wall. Like, what am I doing wrong? I could have swore that I had this, like I was streaming in higher def than this. Turns out I was. It's just YouTube won't give it to me at that definition. So, yay. But I don't know. It's frustrating. It's one of the things about YouTube that I think is, like, that bit me the hardest because I really didn't expect it to happen. Like, I was kind of expecting them to just give me back my default version, because why wouldn't you? And I don't know if there's any answer for it or not. It's just, to me, it's just one of those things that's really dumb, and I don't understand why they do it. But I guess I have to live with it. I don't get to make the rules. Okay. So now that we've rebooted, or we've sent you the right image, sure, go ahead and capture. And let's reset you. Reset you. Let's try this with the right, yeah, we have the right number of bits. See, it installs so much better when you give it the right number of bits. To install Ubuntu. Interesting. Hope that doesn't cause too many slowdowns. Like, I'm already kind of expecting this thing to kind of crawl. But I guess we can live with things the way it works out. I will say this is, in my experience, one of the more painful parts of doing any sort of bug finding is getting a test environment set up. Frequently means building, a dozen VMs to test in, and just every single one of them is like, okay, go. And we're going to sit here for the next 15 minutes and watch dots move across the screen. And then we're going to have more dots move across the screen. And then more dots move across the screen. And eventually the dots will have moved all the way across the screen, and we'll have an image. Yay! But this shouldn't be too bad. Like, this should come up relatively quickly. Once we have this VM built. So we have this VM, which is an Ubuntu 18.04 in Hyper-V. And inside of it, we will have a Ubuntu 16.04 running in VirtualBox. And in particular, it is a version of VirtualBox which should be vulnerable to quite a few CVEs, because it's that 522 branch which had all of these it should be vulnerable to. So we should, assuming all of this works the way that it should work, we'll have all these to take a look at and poke at and hopefully get some cool stuff out of. But we'll have to wait and see. There's all sorts of things that could still go wrong, such as installers not actually installing everything right. Hopefully this is not a, I'm hopeful that this is not their stuff just absolutely crawling on us. Because it should go at a reasonable speed, I would think. Let's give this another minute. Because really, it should go at a reasonable clip, I think. But we can give it a bit. Can I access any of the TTYs? I actually don't know if I can send that across the... Yeah, I don't actually know if I can send that. Because I want to control Alt F1, right? It's like I can't even access it through Hyper-V to this one. So I assume that it's... Okay, let's reset this. Let's see if we can actually just drop into the try Ubuntu. Yeah, I know you don't support things. Yeah, I don't know why the VM isn't... No! Son of a... Ooh, you're going farther, though. Getting more dots. The dots are moving. This is exciting. This might be working. Okay. Are you kidding me? Okay. I'm hoping it's not doing what I think it's doing, because if it is, I am very unhappy with software working this way. But we'll give you one more opportunity. Because I think what just happened is that as soon as my mouse left the window, the dots stopped moving, and I assume the installer stopped with it. Blah, 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 blah. Yeah, spectrum mitigations, I got it. Come on. Okay. I'm now not going to touch my mouse, and hopefully it actually goes to the spot it's supposed to go to. Nope. You are dead again. Okay. So why didn't it give me the other option? So let's shut you down. Shut you down. Just power off. Don't care. Not doing anything useful anyway. No, I want to... Other options. That's weird. The F keys don't appear to be being sent at all. So the reason I'm doing it this way is to make it easier to debug. I want the it's going to be easier to debug the VirtualBox host inside of VM because there's a chance that it makes the host kernel panic. So having it in Hyper-V is just going to make this a little bit easier. At least I'm hoping it will be. Control. This doesn't tell me what I want at all. I'm not. I'm still using just the default version of it. So disconnected, I'm just using the 5.2.22 that is prior to the latest round of patches. Right now, I'm just trying to get something working that will let me validate I can at least crash it. Why are you being a piece of crap? So like F1 is not getting sent at all here. Okay. No. This feels dumb. I really don't like how much of a problem I'm having with this. Like, it should just be working, I would think. Well, so we actually got this far. Let's see if we can get this far. Can we boot into their, like, fake version? By fake version, I mean, like, live CD Ubuntu. Because if so, that at least gives us some place to work from. My, very basic understanding of how that thing actually works tells me that I should be able to still install a kernel module, which means I should get it working at least. I hope. Nope, we are dying in exactly the same spot. Okay. I thought there was a way to do this. Okay. Yeah, here we go. While the virtual machine is in the off state, I should be able to run this. So you need to stop. Turn off. Turn off. Power shield. You're gonna need a admin prompt. Is that a full name? That's kind of painful. To 18.04.1 LTS dash that $true. Can I show? Ooh, that's not what I want at all. Like, I want you to just start normally. It's not F. It's the letter capital A. Am I being dumb here? Well, it's an off state, run it. Huh. So clearly this is causing the problem. But why? Like, I would expect that to work. This is annoying. But why won't you work? Okay, nested virtualization. EPT technology. Oh. That's why, actually. It's because I got an AMD processor in this. Grumble, grumble, grumble. Of course this isn't going to work. I guess I'm being bitten for not the first time for using a going with an AMD processor in this thing. Okay. Yep. Because if we remember back to what was it, last summer when I was, or no, it was a year and a half ago when we were looking at that Intel bug, and I had to jump through a bunch of hoops to SSH into it. Yeah. Okay. This kind of sticks me for a little bit, doesn't it? Because the way I want to do this, I'm not sure I can. I think what I'm actually going to have to do here is I'm going to have to take some time, set up another box, and just run all of this bare metal on it. Because that's probably going to be the easiest way to do things. If I get another box and just throw it in the corner here, run bare metal Ubuntu with a VirtualBox VM on it, is probably the easiest way to set it up. But that's something that I can't easily do on stream. Well, that's weird. Huh. How does that happen? So I can't actually see Hugo's link in either of my chat windows I have open, but it is apparently in the built-in video on the stream. That's a little annoying. Okay, so this is where we are actually at. So we built a VM. We failed to make VM in VM because reasons. Yeah, it's really weird that the like overlay is still displaying it, but none of the chats have the link in it. And I don't even see how to, like, I think usually it gives me like a little moderator thing here that it says, oh, do you want to let this link go through? But, oh, there we go. I have to manually change to live chat as opposed to top chat, and now I can see it. There we go. Yeah. Okay. Yeah. So we failed to make a VM in VM. What else have we done here? So we did look through this a little bit. Let's check these off. We didn't go through many of these, but I think it's okay to check those off. So we failed to get our VM and VM working. So I think what we're going to do is off stream. We're going to build Linux bare metal. We're going to make VirtualBox VM on it. I think it's probably going to make the most sense. Rather than trying to do this all on stream and failing, I think just doing it off, like, make a bare metal VM. Yeah, but then so the biggest issue is that my desktop is running Windows, and I don't think there's an easy way for me to push it through. Like, I think there's a way to do it with VMware, but I've got a pile of laptops beside me. I might as well put one of them to use and actually just set it up. Doing that on stream isn't going to work at all. Like, you'd get to see a blank screen while I fiddle with it, and I can hum to myself. Which, you know, probably isn't ideal for stream quality watching. Is there anything useful we can do before we jump into that? I don't think so. Because I kind of want, like, I think one of the only other big thing we need to do is start building a device driver to try and crash that CV. And while we could start doing that without having a working test environment, it's going to be a lot harder without a working test environment. Just because I don't have any good way to test any of the code I write. So when it comes down to it, let's pick one of these real quick. We can do that now. Let's try and make, because it was the first one we looked at, CVE. So we're going to try and get this. So in order to do that, we need to build kernel module. We need it with that, like, ioctl that we can push into it. So we're gonna add an ioctl to send message, and the message we actually want to send, if we go, this one looks good, right? And we're waiting. And we're waiting. It is really annoying how slow a lot of these are. Like, I feel like it should be fast, and it's just so slow. Why is this so slow? This one I would expect to be pretty fast. Am I screwing this up somehow? How do I screw up searching? Awesome. Thanks, Hugo. I definitely appreciate the nice words. It's great to hear that people are enjoying the streams. Okay, here we go. I assume that you're talking about the technical content, not the bad humming that I do while waiting for things. While it is a service I provide, I doubt it is the reason most people are watching streams. Oh no, I want this thing. Without the space. Okay. So this was the thing that we had before, right? Where we wanted to send a CR server dispatch get active uniform message across. And we actually wanted the we want the buff size, which is one of the arguments we send in, to be a negative number. And that very small negative number, like -1 or something. Or no, we want it to be roughly the same size as this. So we want it to, let's do these in a different order. So that moves down. Actually make this a top level thing. So for this bug in particular, we need to print k that. And the reason to do, so we're going to use print k to actually log out what the size of this is. There's other ways to do it, but that's probably the easiest way to do it. And then create a message where buff size is equal to negative that size. And I think that should give us a crash. Well, it's going to give us heap corruption if we do that, because if we create a message where buff size is negative this size, or that size -1, or would you say 1 minus that size? Right, so if it's 1 minus this size, then what we're going to actually try and alloc here is going to be 1. We'll allocate 1 byte, and then when we come in here, we have plocal. Plocal is going to get passed in here, and it's going to fill out all these variables on it. It's going to fill out the length, the size, the type, and it's going to throw bytes into whatever this is. So we should see heap corruption, and we should see the host process crash because of it. In theory, I think. Maybe. So I think that's about it. Trying to think if there's anything else we can really work on right now without having a good test environment. We've gone through a couple of the CVEs, and we didn't find a whole bunch, but we did find some stuff. Ooh, that's what we can do. So rather than going through stuff right now, let's do, oops, look guest additions. Inits. So one thing we can do right now is we can actually go through some of the guest additions. So if we come in here and in the common code, need to use ag. Oh, that's a lot more than I thought it would be. Oh, maybe it's not. How much is this? Oh, that's a lot more than I thought it would be. So I want it to be init itself. Ag dash. Is I gonna be? I want it to be case sensitive. Okay, how many are we at now? 600 lines is way more than I would like it to be. Bad regex. There we go. So what we just did there, so I'm searching for every function which has an init in the name of the function, and I'm assuming that they're going to properly camel case their stuff, which seems like a plausible thing to expect. And I'm hoping that this actually tells us somewhat reasonably some of the stuff that we're going to be doing here. One of the things that's particularly interesting is I actually want to see this function. Where does this thing get used? So this... A what? Vim VBox video. I'll go in the exploit version of it. Setup host context. So this is where they added their, the write-up author added their ioctl setup stuff. So where is this getting called? I hate computers. Okay. Well, that actually isn't helpful at all. Please tell me it's someplace else too. And that we're not doing one of these wacky generated code things again. That'd be kind of a pain in the ass. Son of a bitch. I really don't feel like it's that much to ask that it be easy to figure out where the crap functions are getting called from. So like this decal hidden is probably expanding it. Oh, is this not what I wanted it to be? No, this is what I wanted it to be because it's a modified one that adds all that code. This is me being annoyed now. Because I was hopeful we'd be able to poke around a little bit and see, oh, this is getting called from blah, 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 which means that we're able to easily do this. Let's just verify this real quick, that I'm not crazy. Hopefully this isn't like someplace else where it's like maybe holding out hope that this gets jammed someplace else too. So those are the 4 that we know about. We have our tags file, which we know about. That's okay. It's not great, but it's okay. Come on. Anything? Anything? Come on. Oh. So I guess while I'm sitting here waiting, for people who are actually watching these live, or I guess if you're watching this after the fact and want to leave a comment, are the recap videos particularly helpful? I know there are a whole bunch of people who had requested like some kind of easier to digest form than like a 2 or 3 hour long stream. That it's a big commitment to try and sit down and watch a long stream. Like I definitely don't watch as many as I'd like to. So I've been trying to make these like 5-ish minute recap videos. So I'm kind of curious, like how useful are those actually to people? Because you get to skip over things like this right here, where I'm going, how the shit are you getting called? Like, how do we have a function which clearly is apparently getting called, but that doesn't have any references anywhere? Ugh, I hate computers. Okay, what's a decal hidden? Well, that's not what I want at all. What is this? Interesting. So this is some sort of... in their code, it's in the WinNT stuff. Okay. I hate you so much, computer. It's not true. I don't hate you. I'm just frustrated. Okay, so it looks like this approach is not necessarily going to work. I was hopeful that I'd be able to easily find what the interface is that calls this thing. So what is a decal hidden? Can we maybe decal hidden? This easy to find? Well, there's not a ton of these. So maybe this isn't too bad. So we had this, right? Which was our, where is it? So 43,878 had all of this, which 43,878 was the exploit code. Well, the like handler exploit code stuff. We have our HGSMI base, which had in it this, what's the function called? We wanted VBox HGSMI setup guest context was where they added their code. So I guess there might not be as easy of a method to jumping into this as I was hoping there would be. It's also interesting. Oh, well, actually, let's go in here real quick. CR OpenGL. So this is the like Chromium OpenGL stuff, which we know what these are, kind of. We know that they're a thing. We're going to be lucky enough and able to just go. No, we are not. Okay. What I was hopeful for here is that, so our goal is going to be to set up one of these Chromium connections, however that works, and then send one of these messages across with an invalid buff on it. But that means we're going to have to actually set everything up to make that work. Okay. Well, given how much we're going to have to jump through to make this work, I think this might be kind of an appropriate place to stop the stream for this week. We've been going for about 2 hours now. It's a little bit less than 2 hours, but close. We have a good grasp on things that need to happen. So between now and next week, I need to build a bare metal test setup because apparently my setup here isn't going to work for it. We also have plenty of stuff to actually work on next week. When we have that test set up, we're going to be able to build the kernel module, we'll be able to set up ioctls, stuff like that, and we're just going to be able to hopefully jam stuff through. So I think it's about everything that we're going to be able to cover this week. If anybody has any questions, let me know. I'm always happy to listen or try to answer. I don't know how successful I'll be, but I can try and answer. And other than that, I hope everybody found this pretty interesting, and next week we'll be back poking at this again, and hopefully next week we'll be able to find a crash pretty early on. Well, not find. We know where the crash is, but actually trigger the crash we know about is going to be the goal. So thanks again, everybody. Thanks for showing up, and hopefully we get this going pretty quickly next week. So I will see you all then. Bye.
myself. I'm cold steel stainless. My glass half full. Always said don't suffer no fools. Serpents, they dream. I bite, you call me lovely. Got a sweet tooth. I'm gonna get the sugar from you. When they say I'm a machine gun, I take it as a compliment. Honey, you should know I can be a weapon. I can be a weapon. Come cold blood, selfish. Your words are painless. I like when I drive and feel so dangerous. They say I'm a red flag, 'cause they want it so bad. You should know I'm holding on to what I had. When they say I'm a machine gun, I take it as a compliment. Honey, you should know I can be a weapon. I can be a weapon.
Wap, wap. Wap. Wap, wap, wap. Oh, baby, baby, I want to feel your wap.